Intuition, integration gives the area under a curve. On the graph, the blue curve is f of x. We can approximate the area using rectangles. These are called Riemann rectangles. With wide rectangles, the approximation is rough. But as we make them thinner and thinner, the rectangles fill the area more precisely. In the limit, we get the exact area, and that is the definite integral from a to b of f of x dx. The integral sign, dx meaning with respect to x, and c for the constant of integration, these are the symbols of integral calculus. Integral calculus, antiderivatives, and fundamental integrals involving algebraic, trigonometric, exponential, and logarithmic functions. From G Main Unit 8. Essential for Class 11, 12, and G preparation. What is an antiderivative? You already know differentiation, the forward operation. Differentiating x cubed gives 3x squared. Integration is the reverse operation. If we are given 3x squared and asked, what function has this as its derivative? The answer is x cubed plus c. Think of it as undoing differentiation. The top arrow shows differentiation going forward. The bottom arrow shows integration going backward. Formally, if f prime of x equals f of x, then capital F of x is called the antiderivative of f of x. Integration finds the original function from its derivative. Visual intuition, integration gives the area under a curve. On the graph, the blue curve is f of x. We can approximate the area using rectangles. These are called Riemann rectangles. With wide rectangles, the approximation is rough. But as we make them thinner and thinner, the rectangles fill the area more precisely. In the limit, we get the exact area, and that is the definite integral from a to b of f of x dx. The integral sign, dx meaning with respect to x, and c for the constant of integration, these are the symbols of integral calculus. Why do we always add plus c? Watch, the derivative of x squared is 2x. But the derivative of x squared plus 5 is also 2x. And x squared minus 3 also gives 2x. In fact, x squared plus any constant c has derivative 2x. So when we integrate 2x, the answer is x squared plus c, where c can be any real number. On the graph, every parabola is a valid antiderivative of 2x, they're all shifted vertically by different constants. This family of curves all have the same slope at every x value. The plus c represents this entire family. Never forget the plus c in indefinite integrals. The power rule for integration, the most fundamental formula. Integral of x to the n dx equals x to the n plus 1 over n plus 1 plus c, valid for all n except n equals -1. Why does this work? Because differentiating the answer gives back x to the n, it's just the reverse of the power rule for derivatives. Here are the most common algebraic integrals. Integral of 1 is x plus c, integral of x is x squared over 2 plus c, integral of x squared is x cubed over 3 plus c. For negative powers, integral of x to the -2 is -1 over x, fractional powers work too, integral of root x is 2/3 x to the 3 halves. Critical exception, when n equals -1, the formula breaks. Integral of 1 over x is natural log of absolute x, not the power rule. Algebraic examples. Example 1, integrate 3x squared plus 5x minus 4. Integrate term by term using the power rule. 3 times x cubed over 3 plus 5 times x squared over 2 minus 4x plus c. Simplify, x cubed plus 5x squared over 2 minus 4x plus c. Example 2, integrate x cubed plus 1 divided by x. The trick, divide each term by x first. This becomes integral of x squared plus 1 over x dx. Now integrate x cubed over 3 plus natural log of absolute x plus c. Remember, always simplify the integrand before integrating. Trigonometric integrals. These are simply the reverses of trig derivatives you already know. Integral of sine x is negative cosine x plus c. Integral of cosine x is sine x plus c. Integral of secant squared x is tangent x plus c. Integral of cosecant squared x is negative cotangent x plus c. Integral of sec x tan x is sec x plus c. Integral of cosec x cot x is negative cosec x plus c. The pattern, just reverse the corresponding trig derivative formula. On the graph, the blue curve is sine x, and the green curve is negative cosine x, its antiderivative. The shaded area under sine from 0 to pi equals 2. Trigonometric examples. Example 1, integrate to sine x plus 3 cosine x, term by term, 2 times negative cosine x plus 3 times sine x plus c. Result, negative 2 cosine x plus 3 sine x plus c. Example 2, integrate tan squared x. There's no direct formula for tan squared. The trick, use the identity tan squared x equals sec squared x minus 1. Now integrate, integral of sec squared x minus 1 equals tan x minus x plus cgap. When you see a trig function that's not in the standard list, use identities to convert it to standard integrable forms. Exponential and logarithmic integrals. Exponential, the integral of e to the x is e to the x plus c. Remarkable, e to the x is its own integral and its own derivative. For a general base, integral of a to the x is a to the x divided by natural log of a plus c. Logarithmic, the integral of 1 over x dx is natural log of absolute x plus c. Why absolute value? Because natural log is only defined for positive numbers, but 1 over x exists for all x not equal to 0. The absolute value handles the negative x values. On the graph, the red curve is 1 over x, and the green curve is its antiderivative, ln x. Examples with exponential and logarithmic functions. Example 1, integrate e to the x plus 3 to the x, e to the x integrates to e to the x, 3 to the x integrates to 3 to the x over ln 3. Answer, e to the x plus 3 to the x over ln 3, plus c. Example 2, integrate x squared plus 3 over x, split the fraction, x plus 3 over x, integrate x squared over 2 plus 3 ln absolute x, plus c. Example 3, integrate 5 e to the x minus 2 over x directly, 5 e to the x minus 2 ln absolute x, plus c. Notice how all types, power, exponential, logarithmic, can appear together in one integral. Key properties of indefinite integrals. First, a constant multiple can be pulled outside the integral. Second, the integral of a sum or difference equals the sum or difference of individual integrals. Integrate term by term. Third, differentiation undoes integration, d by dx of integral of f of x dx equals f of x. Fourth, integration undoes differentiation, integral of f prime of x dx equals f of x plus c. These two properties confirm that integration and differentiation are inverse operations. Critical warning, you cannot split the integral of a product into a product of integrals. That's a common and dangerous mistake. Final example, a mixed integral combining all four types. Integrate x cubed minus 2 sin x plus 4 e to the x plus 5 over x, integrate each term separately. X cubed gives x to the 4 over 4, that's the power rule. Negative 2 sin x gives positive 2 cosine x, trig integral. 4 e to the x gives 4 e to the x, exponential integral. 5 over x gives 5 natural log of absolute x, logarithmic integral. Combine everything, x to the 4 over 4 plus 2 cosine x plus 4 e to the x plus 5 ln absolute x, plus c. Pro tip, always verify by differentiating your answer. Key exam tips. First, never forget plus c in indefinite integrals, it's the most common mark-losing mistake. Second, power rule, add 1 to the power, divide by the new power. Third, 1 over x is the special case, it gives ln of absolute x, not the power rule. Fourth, e to the x integrates to itself, simplest function in calculus. Fifth, always simplify the integrand first, expand brackets, divide fractions, use identities. Sixth, for tan squared, cot squared, use the Pythagorean identities to convert to standard forms. Seventh, verify every answer by differentiating it back. Eighth, constants can be pulled outside the integral sign. If you found this helpful, like and subscribe for more JEE and board exam solutions at MAGPIEHUB.